Okay, good day everyone. So now we are going to do we call the mesh analysis. So last week we are doing the node analysis. So hopefully you have done the last question example 3. Okay, successfully using the knowledge that you have learned. So this week we're going to complete the last part of our chapter 3. There is a mesh analysis. So in this slide, you're going to explore the step-by-step instruction for the mesh analysis, which is a method to calculate the voltage drop, okay, and mesh current that flow through loops in a circuit. Okay, unlike the node analysis that we learned, the one we're going to find the VA, VB, or V1, V2. Okay, for the mesh analysis, we're going to find the current source. Okay, so mesh is the smallest loop around a subset of components in a circuit. Okay, multiple mesh are defined so that every component in the circuit belong to one and more mesh. So this is some definition. So anyway, let us see how we're going to do. So this is the question that is similar to what we did in the node analysis. Okay, exactly the same thing. So in the node analysis that we have 1, 2, 3, 4, 5 node. I'm correct. 1, 2, 3, 4. 1, 2, 3, 4, 5, 5 node. So this means we have 5 unknown voltage that we need to come up 5 equations in order to solve that thing. So it's slightly complicated. But when we're using the mesh analysis, it will be much simpler. Okay, so that's why sometimes if you are not required to using specific method, that you need to choose which is easier one for that question. Okay, both of them have the pro and cons, so it depends to the question. So step 1, identify all of the mesh in the circuit. So how identify? So the mesh is something like you see in this diagram. Okay, the I1 and I2. So that in other words, in this circuit we only have 2 unknowns in terms of the current. So that is the I1 and I2. So first, of course, we fit the current flow direction. As you can see in the slide, it will be in the so-called clockwise. Okay, so it's a clockwise. So we do the marking as you can see in the slide. Okay, and in other words, the I1 will go through the R6, R1, and R2, and then the I2 will go through the R6 and R5. So for the R3, so there will be 2 current. Okay, there is the I1 and I2. Okay, so later I will show you how to come out the equation for this circuit. Okay, so of course there is what we call the label. But anyway, I think the label for this one is incorrect, so it should be the polarity should be reversed. Okay, so I think this you should take note. Okay, minus, since our current flow from the source to here, so here is will be a plus. Okay, so you take note about this. And then okay, so the rest should be okay if you see. Okay, so positive, negative. Okay, so this one okay. Label voltage across this one. Basically is optional. Okay, for me. So you can label. Okay, this one's the wrong thing. So you please, I think after I correct this one, what you receive should be the correct version. And then this is a Kirchhoff voltage law, the equation that we get. Okay, so that's mean V in. So if you follow the direction, okay, so we start at, let me take a arrow to show you. Okay, arrow will be okay, let me take this one. Okay, so as you can see, we follow the clockwise, so that means we come from here. So here what sign you see is a negative, am I correct? So that's why you write negative V in, okay, in the equation. Okay, V in. So next should be the positive, okay? It's moved to that, it's a positive. So this one is wrong, right? So I cannot change. And yeah, you take note about it. This is the positive, okay? Since we label is positive, the column flow inside. After that, the column flow to here is a positive. What I can do? Okay, so this one is correct. So plus. Okay, so perhaps I can add something like this one, okay? So there you are aware there is the arrow. Okay, plus. So plus V2, the one okay. That plus V3 also okay. And then the column flow to here, the loop that we grab until here plus the V6 of them equal to 0 as we using the Kirchhoff's voltage law. Okay, the one is our first equation. Second equation also, okay, it depends. So you can, yeah, it start at here, should be okay. So what you see here is a negative, am I correct? The negative sign. Okay, so when the current I2 move to here, you see this component is in the negative. So that's why you see negative V3. That the next component is a positive V4. So you write positive V4. And then lastly is the, excuse me, okay, it's a V5 positive. So that's why you write V5 positive equal to 0, okay? So this is the two equation in the step 4. Okay, so please pause if you need to think a while, okay? And this is what you already know, so that we go further. Basically is when the column flows, so you see the positive. Okay, and then next is the what is we come on the equation. This one is how we substitute inside to the equation. Okay, so that's why you see here is some funny thing because they write negative I. I don't know why they do this thing. So basically, as I mentioned, we only make it positive. So that's why it's unnecessary to put a negative there. Okay, so okay, so actually it's positive already because we look and after we change the polarity, of course. Okay, so that original slide is no, that makes sense. Okay, so this one should be a basic Ohm's law. So I'm now going to explain further. So basically, you need to substitute them inside the equation that we create. This equation that we create, and let me group them. And then okay. So here you can see I1 and I2 only two unknown. Okay, so that's mean after we substitute this V1 to V6 to that two equation. So the equation is sufficient for us to do the simultaneous equation to get the unknown V1 and V2. Okay, so once the mass current are known, the calculate voltage across all the components that we can calculate, okay, as they mentioned. So the one should be understood. So this is an example. So let's say you are given the R. So again, this one is incorrect. So please take note about this thing. Okay. So we normally no label like this. Okay. So we label according the column flow. Okay. So it should be positive here, negative there. Of course, if you insist to label like this, so that's why you somehow create a negative sign and after that you need to turn it back into a positive. So it's something that I not so sure why they do such thing. Anyway, so either one you should get the correct answer because you can see here negative and then they put here negative and then after you still get back the positive. So for me it's redundant step. Okay, so you don't need to follow that thing. So as here also demonstrate after you substitute all them inside, you're going to see I1 and I2 in each equation. Then after that you group the equation. So that means you have a matrix, okay? you have a matrix. So maybe I can write a little bit. So here, assuming what they write is correct. So by right, you have a 12. Okay, and then plus 4. Okay, the first one is 4 kilo ohm, 4K. And then the next plus 8K. And then you plus again. Plus again, here you have a 5K. 5K, and then you plus again, the last term is a 1K for the I1. Okay? So I1, let me make it subscript. Okay. That we plus. Oh, okay. Plus I. And then next is a coefficient of our I2. I2 is a minus, as you can see here. Minus 5K. Minus 5K. So this is the thing that equal to 0. Let me see, it's too small. It's okay, so I copy here. Equal to 0. Okay. So this equation that we get, okay, after we grouping, of course, the minus 12, we can move to another direction, so it becomes a positive 12. So the first equation that we get is this. Hopefully you get the same thing. So please again pause the slide, pause the recording to get this one. And then of course here after simplify, I will get how many? So this one is 18, okay, 18K. So 18K. Am I correct? So yeah, should be correct. If not correct, please email to me about, and then let me know the time that you identify the error, the typo error, or the error that I have made. Okay, so I will welcome to the email. Okay, so remember I put the K there, so this is a coefficient. Okay, how about the next equation? So again, we don't want to group the I1 and I2. Okay, so from so I copy the framework. Okay, so to get the equation 2, so what is the coefficient of this I1? So normally it should be plus and I2. So what is the coefficient? And then the constant as well. I think for this one, the constant is 0, or we don't have a constant. So for the I1, we have a minus 5K. Okay, for this time, we have a minus 5K. Okay, of course, here you can add the plus, and then here you add the minus there to indicate the coefficient is minus is also good. Okay, because after that we want to transfer into the matrix. Or of course, you can using your calculator to do the simultaneous equation. So next, I want to group the coefficient for the I2. So for the first term, minus, so I have positive 5K. And next, I plus the positive 6K. And then I plus again the 3K. Okay. So total, what I have, of course, in the exam, you can write the next step. Okay. So here to avoid too many things. So I can just give you the answer. So I have a 14K. Okay, 14K. Okay, so now you can do the simultaneous equation to get the answer using your calculator. So hopefully you know how to use the calculator to get this answer. So don't need to using the matrix actually. And also don't wasting too much time. Okay, so in your calculator, you should select the simultaneous equation. If you don't know, you can go to Google. The YouTube, I think, should have a tutorial. So after that, you key in the coefficient. Remember, we are in kilo ohm. So make sure you enter the kilo. So I am now keying the value into my calculator. Okay, so you can do the same thing now in your calculator. So eventually, after I enter, I get the first the I1 equal to 0.0007 ampere, and I2 equal to what? Let me see. I2 also very small, 0.0003. So this one I think is not that accurate because my calculator I fit in the 4 decimal places. So please what we call avoid this thing. So I need to change the format. Okay, so I change to the fit, the one to fit, we change to the scientific. Okay, so scientific here, what I get actually is more precise. So it will be 0.74 milliampere. Okay, and then next Y will be 0.264 milliampere as well. Hey, no, this one not milliampere. So the milliampere will be 26.3. Okay, milliampere. So this one for the calculator. So is the answer correct or no? So we move to here, look like it's correct because it go to the microampere. So if we move to the microampere, yeah, so it's the 740, okay, microampere. Here we move, okay, at this thing we multiply to, wait a minute, this one typo. Okay, so if I change it to the milli, I get, okay, let me type the calculator, 2.643 times 10 to power -4, okay, so -4, we make it -3. So meaning, yeah, it should be smaller. Okay, I move wrongly. Okay, so should be like this. Okay, because yeah, we make it -3. So this means the answer need to multiply to 0.1. So it should equal to this guy, 0.264. And after that we convert into the micro. Okay, for me to micro, so this means we multiply to 1000. So we're going to get this answer. This means the answer in the slide is correct. Okay, it's correct. Okay, so this slide is correct. Okay, one or more of the mesh color may have negative side. It depends. This one depends to how, but no, in the norm we will crosswise. Okay, you fit this one. So if you here crosswise, here you try anti-crosswise, that will know a good practice because you will confusing yourself as well. Even though eventually you can get that's the correct answer, but if you increase the chances for you to get a wrong answer, so don't do such thing. Okay, and then after done that thing, you have I1, I2, so you multiply to its respective resistor that you going to get an answer. Here should be correct, but I also identify a typo here. I think should be the right one. So okay, as you know that typo is unavoidable sometimes. It's okay. So the important thing is you understand the fundamental thing. So I should ask any question now, but I think you cannot answer me now since we are doing the asynchronous learning. So do email me by screenshot the question that you want to ask me. Okay, so please screenshot again. Don't send me the zip file. Okay, so the one. Okay, and then this is they say that this means you can using the knowledge that you get from your chapter 1 and 2. Okay, this means you calculate the equivalent resistor or the total resistor of a circuit, and then after that you divide to get the I in or I equivalent, so the input supply to the whole thing. So you're going to get the I1, okay, according to the circuit. And then next is the exercise. Okay, so please pause the slide and pause the slide. Pause the video now. Okay, spend as long as you like to solve this one before you proceed to the next question. No, next question. The next video. Okay, so let me record several one. I record all in the one. Okay, I think you pause only so that I don't need to upload so many times. So you pause your video and solve this one on your paper, just like how you did in the class. So after you done or after you start too long, you may process the video to see the answer or how I solve it. So basically, to solve this question, okay, so we need to draw the current flow in our mesh analysis. So in the question, so please read carefully what they want you to do. So yeah, okay, I think quite okay, even though, let me draw this. Okay, is somehow, okay, good. No more good already. Okay, okay, I think you can understand. So here, this is my I1. Here, start at here. Okay, I1 like this. Okay, I2. Okay, I hope that this output should be no affect, no be a barrier for your learning. Okay, so should be understood. So we make them crosswise. Okay, like this. And next, what we want to do is we come up with equation. Okay, let me take my framework. This is my framework. I think can. Okay, I take the framework. With this equation. Okay, of course, I start with a simple one. Of course, you need to label the voltage first. Okay, so label the voltage. Okay, here it will be you can write it as a V1. V1. And then the positive, negative, yeah, you should draw that thing as well. Okay, so that you will not confusing. So this one I label as a V2. V2 or VR2. Okay, I think VR2 is better. I don't want this R. I want a small r. A subscript r. Okay. R1. Okay, like this. Will be much better. Next here is R3. Okay. And then next, we want to come to the equation. So the equation, of course, we start with our 5 volt and 15 volt minus 15 volt because we are crosswise, and then plus this V, okay, R1. I think this one is clear. That we plus again VR2 that equal to 0. So this equation that we get. Okay, hopefully you get idea. So that means we going to, yeah, this good idea. We put the positive, negative first. So it will not be confusing later on. So positive here. Place. So here is positive. So another way is a negative. So I'm no roll that thing. So okay. So first equation done. Second equation. Equation we start with negative V2. I'm correct. second in minus because it come from here. Yeah, here we have another source. Okay, so this equation no finish. 1, 2, 3, 4. Here's another. This means we need to plus plus a 10 volt, okay, equal to 0. So this is the first equation. Yeah, almost miss this voltage source. Okay. And then yeah, actually this is no so good question because it makes the AC and the DC. Okay, so let us assume both of them are the DC. Okay, we assume it's DC. Okay, otherwise we cannot solve it easily. If you want, also okay, that means like what we did in our previous chapter. So that means this AC we maintain. Okay, that means we make it a sine omega t. So we maintain this one. Still okay, the one will be another part. Okay, so normally we will make it as a DC. So we assume here is a typo. Otherwise, you need to maintain AC because we cannot merge the AC and DC at the same time. So if we want to maintain as a AC, there will be a problem because we don't have this one. Okay, so now we maintain first. Later on we assume it's a DC that we remove the sine omega t. Okay, so now we continue the equation 2. Equation 2. Okay, start with actually minus 10. Minus 10 and then minus again the VR2, and then after that it plus the R3, VR3, and then actually we had another V here. He almost missed that thing. Okay. Okay. Here the VR maybe we label as a 4. Okay, VR4. Okay, they're equal to 0. So even though we have more components, unlike the nota analysis, that will add more node, more unknown. So it will make the equation complex. But this one, as you can see, that even we have another resistor, our equation will not be so compressed because we only have 2 unknown, because we only have 2 loop or mesh in here. So what's next? Next is we substitute. Oh, okay, I think this one I don't need already. Okay. So we restructure this one. We label as one A. That means we substitute those unknown. The R, it will be equal to I1. I1 multiply to how many? 5 ohm, am correct? 5 ohm I1. And then next the V2. We are here 1. Okay, here another thing. This one is R3. R3. So that's why every time to recheck again. So it's R3. R3 equal to 10. And then remember there will be a 2 current. One is a positive current here. So you will write the I1. And then another is the opposite side. So you need to put the negative I2 and I1. So I1 minus I2. So at here, after that you plus 10. So this one settle. Okay, so and then just like we did previously, let me let this one smaller. Okay, we want to group the coefficient, rearrange this A0. So we move the constant to another part. So here we have a 10, to here we have a minus 10. Okay, and then this 15 AC. So we move to here. Okay, it becomes positive. And then also the I, this VR we already replace with this equation. V equal to IR. So we have IR here. So next we want to group it is I1 minus I2. Okay. So next you're going to group the coefficient of I1. So you get 15 here. And then you get the minus 10 here. Am I correct? Okay, so this is the first equation that you get. So please let me know if there's a typo. Okay, next equation. This is positive 10. Apparently, we just move to another side. We will get the positive 10. After that, the VR2, VR2. Minus. Yeah, I think this is a typo. And this is the number 2. 2. This is number 3. Number 3. Then move to here. Number 2, positive. Okay, and then 4. Okay, so this one, please take note. Okay, that this means this one should be at number 3, number 2, and VR4. Okay, so let us start again. Minus, minus, positive, positive. Okay, clear. So now we can replace this one. V equal to IR. So the R will be the 10. So I here, now the I will be, because we are from here, so the I2 now is a positive. Okay, I2 is a positive, while our I1 will be the negative, because I1 now is the opposite side, negative. So that's why you see the I2 minus I1. Okay, I2 minus I1. Okay, we'll follow this flow.
In progress.
So actually this will be incorrect. Why? Because we already define our VR3. So that's why we actually need to maintain how we get a positive VR3. So that means the current I flow in, the I1 flow in. So I1 flow in and out and minus I2. So this one need to be changed because we already fit this thing. I mean the sign. So that's why when we look it, so we get the negative, negative 10 volt and then negative the VR3. So this one need to maintain. Okay, cannot be changed. Then we can remove this one. And next is this VR2, VR3 here. So VR3 equal to what? I2, correct, I2 multiply to what? I2 multiply to the resistor 6 ohm. Okay, so this one settle and then R4 will be much straightforward. So it equal to I2 as well, and then the resistor is 4. So we have this equation. That next is we group the I1 and I2. So I1 apparently we only have 10. So and then here minus 10 multiplied to minus 1, so we get positive 10. So total the I2, the coefficient in this equation will be 20, am I correct? Plus. Okay. So this is what we get. And then let's assume that this 515 is a DC. Okay, we assume it's DC. So here how much we're going to get? We get 5 positive. So these are the equation. Next, we're going to use a calculator to solve this simultaneous equation. So 15 minus 10, 5, minus 10, 20, and 10. So we going to get the I1. Okay, I1 answer, sorry, I1 answer equal to 1 ampere. Wow, the I2. Let me click again, calculator, also 1 ampere. So that's mean best use for calculator, you're going to get 1 ampere for both of them. I think the answer should be correct. Okay, hopefully you get a same answer for our exercise 1.